Chapter 1, Section 5, Learning Target Number 1, is about negative acceleration. Negative acceleration can happen in two different ways. An object can be speeding up in the negative direction, which would look like this on a position time graph. The velocity time graph would look like this, and the acceleration time graph would look like this. Remember that these motions all relate. The slope of this line gives you the velocity, and the slope of the velocity line gives you the acceleration. The other possibility is an object could be slowing down in the positive direction, which would look like that on a position time graph. The velocity time graph would look like this, and the acceleration time graph would look like this. Again, the slope of this line gives you the velocity, and the slope of the velocity line gives you the acceleration. To calculate acceleration, we take the change in velocity divided by the change in time. You've seen this before. As an equation, we say that A equals VF, meaning final velocity, minus VI, meaning initial velocity, and divide that by time. Whenever something is coming to a stop, that means the velocity is going to be 0. That's the final velocity. So when you're subtracting any number from the final velocity, you're going to get a negative number, because 0 minus whatever the starting velocity was is going to be negative. 0 minus any number is going to give you a negative number. That's why we refer to this as a negative acceleration. On page 79 in your reading, there's an example of you going to your friend's house. At first, your car is moving forward but slowing down, as shown in diagram A on page 79. When you look at the math, we've got our time measurement here, our velocity measurements here. We have a final velocity of 4 meters per second, starting velocity of 6 meters per second, and a 1 second time frame. That gives you an acceleration of -2. 4 minus 6 is -2. That gives you a negative acceleration. In the next two examples, the car also has a negative acceleration. In the first, the car is moving forward and slowing down, coming to a stop. So the math is the same as in the previous example. In the next one, the car has changed direction, is going the opposite direction, and speeding up. That's in diagram letter B. So now we have a situation where we have a -4 as our final velocity. Our starting velocity was -2, and our time measurement was 1 second. -4 minus a -2 gives you a -2. In the next three examples, there's a positive acceleration. And that has to do with, again, the motion of the car and what's happening to the speed. So in diagram C, the car is moving in the opposite direction as it was originally moving and slowing down. So we have a -4 minus a -6 over a time of 1 second. That's going to give you a +2 for the acceleration, because -4 minus a -6, that's really -4 plus 6, is a -2. When the car continues to move backward but is stopping, is slowing down, coming to a stop, again, doing the math, we end up with a positive acceleration. And then when we have a car that's moving forward and speeding up, as it is in diagram D, we again have a positive acceleration. So this car has a constant acceleration of positive 2 meters per second, or feet per second squared, or negative 2 feet per second squared. Again, it depends on the direction that the car is moving and whether the car is speeding up or slowing down. To wrap up your work with Learning Target 1 tutorial, as an application question, in your notebooks, please give at least 3 examples of objects that are undergoing negative acceleration. These are objects that you are thinking of other than automobiles. Come up with unique examples to show your understanding. Thank you.